Let's start by drawing a diagram of what we might call the eternal triangle, really. There's Charles Babbage, but then there's this other well-known person that we need to include in our story, Ada Lovelace. And in the end, among Charles Babbage's many proposed designs, there was one for what really is the world's first stored program, Turing-complete computer. Is the Analytical Engine. Only problem is it's totally mechanical. Let me link these with double-headed arrows, and we'll move about this diagram, sort of keep it in view most of the time. The sources of material, really, I became aware of these when I went to an Ada Lovelace symposium last December. And yes, it's taken me almost a year to digest it all and to prepare these talks. Let's begin at the beginning, and let's begin at the top left of my diagram. Some of you may recall that actually I did mention Charles Babbage in a video I did on why binary, trying to explain why the binary system came to dominate in computers. Large-scale automation in manufacture wasn't quite there in Babbage's time, and he moaned like mad at the invoices, the bills he had to pay to him. We're talking about the 1820s, roughly, where this story starts, and saying that he was a very celebrated mathematician, but his big forte was that he wanted to actually be able to automate the production, initially, of log tables. Now, those of you at the older end of the audience may well at high school have been taught before, hand calculators even came in, that the way to do multiplications was to turn them into additions by using things called logarithms. So tabulating log tables was the most enormously important thing to do. I've got here the log tables I used at school. And Stephen Wolfram in his blog says that even he, who was rather younger than me, did do multiplication by adding together logarithms and then taking the so-called antilog of them when he was at high school. Those are 4-figure precision log tables. Here, very ancient book I bought second-hand ages ago. These are 7-figure log tables. So therefore, yeah, you looked up logs, you added the logs, you turned them backwards with things called antilogs, and that was the only way for years of doing complicated multiplications. So Charles Babbage actually did supervise the production of log tables, as it were, by hand, before he ever got interested in mechanizing it. So a lot of the early Victorian log tables got Charles Babbage's name on them. But it drove him mad because, first of all, there was the problem of computing these log tables. Worst of all, and he saw very clearly, another big problem was getting them printed. The mathematicians who drew them up might well have got them perfectly right, but they handed them then over to the typesetters for printing, and the typesetters, of course, tried their darndest, couldn't read the handwriting, and made typo mistakes all through, and just checking them was a pain. He came from a sort of gentlemanly background, was not fabulously wealthy, but well enough off to afford a good lifestyle. During his career at Cambridge, he eventually became the Lucasian Professor of Mathematics. Those of you into the history of maths, keen followers of Numberphile, will know that perhaps the most famous Lucasian professor was Isaac Newton himself. And more recently, until very recently I think, where he's given up, Stephen Hawking, the Lucasian Professor of Mathematics at Cambridge. Charles Babbage was not, in my view, as illustrious as those two. I mean, Newton and Gauss and people were just at a level of genius way beyond most mortals. But, he was a perfectly creditable appointment. And like his predecessor Newton, oh boy was he thin-skinned. He couldn't take criticism, and what's more, if he was around today, he would have been banned from email, Facebook and Twitter already. He loved flaming people who were stupid, not to realise the value of what he wanted to do, and even more, the stupid grant givers, because he did get grants to build these engines. They were so penny-pinching and stupid and lacking in foresight. And when people said to him, look, Babbage, You're your own worst enemy. Why do you do this? He had a bright idea. He would continue to flame, but he would write anonymously. And of course his writing style and the fact that nobody else would rant on immediately gave the game away. Yes, it's Babbage again. So this was the backdrop then, but he did actually draw up designs for a very general kind of hand-cranked engine that could do more than just log tables. From a mathematical point of view, it could be set up to do any mathematical problem that could be represented as a function of polynomials. Those who've done this stuff will know Taylor series, Maclaurin series, all this kind of stuff. Yes, a big class of problems, including producing sine tables or cosine tables or lots of others. So you could say that these so-called difference engines of Babbage's were, if you like, special purpose computers. People at the time thought they were totally wonderful, but do remember their special purpose. They can do calculations, but only things that can be expressed as sums of polynomials. Think, if you like, for those who watched the Bletchley Park series, a bit like programming the bomb for whatever is the settings on Enigma today. That electromechanical calculator, the bomb, is a special purpose computer. It can do wonderful things, but they have to be related to the settings for Enigma machines. The difference engines could do wonderful things, but only to things that could in the end be reduced to the method of differences. So don't think these are general purpose computers, they're not. There you were in the 1820s, which was before precision machinery became available, driven by electricity. That couldn't happen until the end of the 19th century. And yet you needed not a few dozen cogwheels that you might need for a clock. You know, a typical clock, maybe a dozen, 2 dozen cogwheels, highly carefully done by precision engineers and all this kind of stuff. You needed hundreds and thousands of these wretched things. And so the bills from the gear cutting technicians to Babbage sent him into a rage. He then passed these on to the government who were funding him. And despite all of this, only little bits of difference engines Mark 1 and 2 were built, which he kept to give people demos. And the yells came from the funders, when are we ever going to see this with these machines realised? You want more money? Babbage, you are joking. We have now given you, at the end of Difference Engine 2 first stage, we've given you £17,000, Babbage. That is enough to build 2 battleships. 2 of Lord Nelson's victories could be built for £17,000. Babbage had not delivered. But like every bad software supplier you've ever known, Babbage had the perfect answer to these critics. Whenever they said, but you haven't delivered, it was always, tell you what, let's forget about the Mark 1. It was not good anyway. I've had a far better idea. Here's my set of plans for Mark 2. And of course they bought it between Difference Engine 1, Difference Engine 2. Maybe a little bit more money would cause it to happen. But when he started getting a whole load of flack about not being able to deliver Difference Engine 2, he had an even better idea. Let's forget Difference Engine 2. I had a far better idea for a machine that will far transcend only what can be done by sums of polynomials and method of differences. This will be able to do basically an infinitely wide range of computations, not just different variants on the same thing. It's wonderful. I'm going to call it the Analytical Engine. Of course it will need at least 10 or 100 times the number of cogs of the ones I haven't built, but never mind. It would be silly to waste more money on Difference Engine 2 when I've had this great vision for the Analytical Engine. Did Difference Engine 2 ever get built? Yes, it did, in the early 1990s. His drawings and his technology were absolutely spot on, and the curator, one of the heroes of our story here, is a guy called Doran Swade. He got the Difference Engine built at the Science Museum. Once he built one of them for the Science Museum, which you can see, after a request from Bill Gates and Nathan Myhrvold, respectively, of course, CEO and Chief Technical Officer of Microsoft at the time, they built another Difference Engine, shipped out to Microsoft headquarters in Seattle, then I think sent out to the Museum of Computing History in Mountain View, But the last I heard is it's migrated back to Seattle, whether back to Microsoft or somewhere else, I don't know, maybe to some other museum. So anyway, it did get built. And what Doran Swade proved was that the tolerances that Babbage set on those gear wheels, how far the teeth were apart and all that, were perfectly doable. And I think it was built in the precision workshops down the base of the Science Museum. But basically, here's the wonderful thing, you know, what did you need to do this properly? Answer, a computer-controlled gear cutting machine in order to get this early technology working, which really wasn't the technology of choice for doing this kind of thing.
I've just been wondering if it's possible maybe to do that with 3D printing now.
You probably could, you know. I never thought of that.
I wonder if people could 3D print an
3D print.
Anyway.
Yeah. So anyway.
There's a challenge to the viewers.
Yeah. So here we are then. Here is somebody who could never finish things. The next release would always solve it. The next release would always cost 10 times more to develop than the present one, which was already way over budget. He did have the vision, and his massive number of drawings, diagrams and so on were vital, and they did work. However, reverting back to the guru, Doran Swade again, let's just finish with the following observations. Charles Babbage adorned his drawings with all sorts of his own shorthand. It was called a mechanical notation. He never wrote a user manual for it, so you had to more or less work out from the circumstances what these little squiggles meant. And as Doran explained to me, it didn't matter too much when he was building Difference Engine 2, because that was so close to other calculators, which go all the way back to Blaise Pascal in 1642. You didn't need to understand every single squiggle. You just could get the idea straight away of what to do. Not so with the Analytical Engine, which is far more complicated. Is there going to be an attempt to rebuild the Analytical Engine? Yes, and it's underway. And Doran Swade is in charge of a BCS specialist little group looking at this. And if it ever gets built, it'll be built at Bletchley Park, I think, is the current idea. So I asked Doran, I said, well, if I understand rightly, Analytical Engine got so many cogs, you can't hand crank it out the question. Babbage was going to drive it by steam. I do hope if you ever build a replica, and his face went like that, he said, you can forget any idea if we ever get this thing built, and we're talking decades, not single years, right? We are not going to drive it by steam. And also, we really cannot make progress until we understand Babbage's notation. So that's the state of the art at the moment. They're trying to understand some of the really obscure things in the analytic design, which just have to be understood before they can make real progress. There were other things in here called variable cards. Those really were to stipulate where things might be stored. You might have a reader number card, but you would then